Okay, I'm going to think through some of this problem number 17. It says we have 18 equally spaced pins form a circle on the geoboard below. The measure of the diameter of the circle O is 10 centimeters and M is the midpoint of AD. Okay, so first of all, what I'm going to do is I'm going to figure out, since it's a circle, there are 360 degrees in a circle, and because there are 18 equally spaced pins, I'm going to divide it by 18, and it tells me that there's 20 degrees of angular measurement between one pin and the next. So from this pin to A to that pin has to be 20 degrees, and from that pin to that pin is 20 degrees. So the first question to ask, what is the measure of arc AB? The arc AB is the angular measure from A to B, which is 40 degrees. And we're going to apply the same logic for BC. To get from B to C, we're going to go 1, 2, 3, 4, 5, 6, 7. We got 7 of those pins. That's 7 times 20, which means that is 140 degrees for BC. Okay, and the next one is a length. The length from B to O. The length from B to O, or B to O, I recognize that as a radius, and they told me that the radius, or the diameter of this thing is 10. So if the diameter is 10, we take half it, and the radius is 5. So the length of the radius, BO, is 5. And then they asked me the length of BC. Okay, well, I'm going to clear some of this to help me find the length of BC. Well, BC is clearly this chord running from B to C. We want to be able to find its length. What we just got done figuring out is that this arc out here is 140 degrees. Well, if the intercepted arc by that chord is 140 degrees, that means the central angle in here is also 140 degrees. But remember, we want to try to get into right triangle trigonometry so we can use SOHCAHTOA and Python. So rather than using that 140 degree angle, what we're going to do is we're going to connect the center to the midpoint of the chord. Now, if I go from the center to the midpoint, it automatically creates a right angle. Remember, center, midpoint, and perpendicular are the three ideas that you need to keep in mind. But as soon as you do that, this 140 degree angle gets cut into half into a 70 degree angle because we've created two congruent right triangles. We have the shared side, we have a right angle, and we also have the radius, so we have a hypotenuse leg congruency theorem for the triangle on the left and right. So triangle 1 and 2 are congruent by hypotenuse leg. Well, that's kind of a long version of it, but what I really want to get you to realize is every time you do this, you're going to bisect that angle as well. So now what we know is that this radius has a length of 5. We know that our angle in our right triangle is 70. We can use that to help us find the length from B to this midpoint. I'll call it M. So if I want to find that length, I'll call that whole length X, and that is the side that is opposite to 70, and the 5 is the hypotenuse. Since we got opposite and hypotenuse involved, I'm going to use the sine of a 70 degree angle equals, and that is X over 5. In order to find X, or the length, we have to take 5 times the sine of 70. Okay? Well, I don't have my calculator out, so I'm going to pull out the calculator and I'm going to do that calculation quick. I'll be right back. Okay, I grabbed the calculator, got it up, and I'm going to type in 5 times the sine of 70. It equals 4.69, so I'm going to round that to 4.7. So the length of that segment is 4.7. Not a very good 4. So if we want to make sure that we get the entire length of BC, we'd have to double that, since that was at the midpoint. So we're going to take this number and we're going to multiply it times 2. So if we double it, that's going to give us a 14 carry the 4. 9.4 is your approximate length of BC. Next, they want us to find the length of CD. And I just want to clean up my image here a little bit, so I can focus on this new problem, which is the length from C to D. C to D, there are two possible ways to work CD. Unfortunately, I missed the line altogether. So CD, this is the one that we're trying to get the length of. There's a couple of different connections that you can do here. Number one, we know that this is a radius, so that has to be 5. This is a radius, that has to be 5. If we apply some of the strategies that we were talking about throughout the lesson, then what we'd want to do is create a right triangle. To create a right triangle, you would have to draw from the center to the midpoint of this line over here, and as soon as I draw the center to the midpoint, it makes a right angle. And that cuts these two triangles, triangle 1 and 2, into two congruent triangles. So therefore, what I can do is I can find the length of just this segment on this part with some trigonometry and then double it. So what I'm going to do is I'm going to use that information to help us do that. But before I do that, I have to also find this angle sitting in here in the triangle 1. What I can use to help me with that is, remember that each of these were 20, so that's 20, 40, 60. This entire angle then would be 60, so the one that I want is 30 degrees because it's half as big. So now I'm going to look through the eyes of the 30-degree angle, and I want to find the opposite side and know the hypotenuse. So once again, since it's opposite hypotenuse, I'm going to do the sine of a 30 has to equal the opposite side, which is what we're going to find, so I'll use y this time, y over the hypotenuse, which was 5. So in order to get y, I have to take 5 times sine of 30. Okay, now that's pretty simple. All we got to do is grab a calculator, type in 5 sine of 30, and it's 2.5. So y has to equal 2.5, and 2.5 was half of that length, so I'm going to double it, so take it times 2, and that means the entire length from C to D is 5. So CD is 5.0. I think we have BC is 9.4. Okay, now the other strategy that you could have used on that, and here's just another way of thinking about the same problem, is because I knew that this one was 5 because of the radius, this was 5 because of the radius, and I also knew that this angle sitting in here, because this was 60 degrees, the central angle is 60 degrees. Well, I'm going to use another little factor that angle D is an inscribed angle. So if I trace angle D up and see what it cuts off on the edge of that circle, I've got 20, 40, 60, 80, 100, 120 degrees. If this is 120 degrees, that means the inscribed angle is half as much, which is 60. Now, if I've got two angles in a triangle that are 60, then this angle has to be 60, and if they're all 60, they're equilateral triangle, which means every side has to be 5 as well. So by equilateral triangle, we can decide if that was 5. So another strategy to get the same input. And then the final thing, what is the measure of angle OMA? So again, in order to make sure we get OMA, we've got to go from O to M, to A. I went to D instead. OMA. This should be a pretty simple task for us because what they're doing is they're connecting the center to the midpoint, and every time the center is connected to the midpoint, it forms a right angle. So what we have is 90 degrees. Okay, and that should take care of what we need to do in that problem.